everybody, and welcome to my talk. Who has not heard this before? Maybe I'm developer A, and I have a problem with my environment. I go to another developer that is a little bit longer on this project, and I ask him, what is the problem? And he says, I don't know. On my machine, it works. This is not good. Maybe this is because the initial configuration and setup of such an environment was completely documented, but all changes that went afterwards, all small tweaks, they went forget, and they get not into the documentation for the second developer or the third developer that must set up his environment with the same documentation. Another version of such a problem could be that I'm working with a tool on a project, and I get on the second project, which works with the same tool, but in a different version, and I may ask myself why the first project always uses now the newer compiler version. And this is kind of isolation problem, that we have multiple projects on our machine and multiple tool chains, and every project interferes with each other. But this is daily business for us developers. We work on multiple projects, we have multiple different tool chains, and we switch each project between those tool chains, maybe multiple times per day. Another thing is that we have to collaborate with other team members that all also have the same environment, or they should have the same environment, that this first sentence do not appear, hopefully. And the third case is that we also need to ramp up new team members that want to start to work on the project, and we would like to have them set up very fast to be productive and not to spend something like a day or two to set up only his environment, to have the same consistent environment than I have. So all these points, they have some problems in it, and we need solutions to prevent them. And this is what this talk is about. I will talk about how to maintain a consistent and reproducible development tool chain or development environment. I will show you how to set up and configure tools that we do only configure them once, and I script them, and I give this script or this documentation that is automated to the second and the third developer, and he has only have to play the run button, and the setup will start up and is consistent with my setup. And in the third case, if I or someone else broke his environment completely, or we do not know what now is the problem, we can simply destroy this environment and set up it again in a few minutes and work again with the newly and still consistent environment. I will answer all these questions and present you multiple solutions to work with that. About me, I'm Christian Lang. I'm originally a trained electronics technician and studied computer science afterwards at FHNW. I'm employed almost 10 years right now at SCS in Zurich in the high performance department. My specialities are C++ development, mainly on embedded platforms like Yocto or Zephyr-based one, usually with Linux. Sadly, my main PC is still a Windows machine. And I do also often performance optimization for multiple projects. SCS, by the way, Supercomputing Systems, is a very good place to work. If you're interested in, we have many different industry sectors where we work on, may it be high-level software or low-level software in embedded. We also have projects that work in the cloud. We have also AI and data analytics departments, and sometimes, or almost always in my projects, we also provide the hardware and sometimes FPGA accelerators to the customer. Another thing that we really try to support is the education of our employees. And one thing of this effort is to jumpstart new employees, new trainees, or new students that work at SCS. And we try to give them a little bit of a refresher and also show them a little bit of advanced topics in different areas that you can see here. All these courses are open source. You can find them on GitHub, all the slides. And if you're interested in, we also, or you can also attend as external. You have only to ask. Yeah. By the way, the whole environment for these Jumpstart courses is also a scripted development environment and is fully automated in this repository. So back to the topic. What are now the solutions that we can use? Maybe at the first point you think about something like that. Okay, when a problem occurs, I try to fix it. Maybe if the second developer gets the same problem, I know already how to fix it. Maybe his problem differs a little bit, so you spend always this time to fix such problems individually. Or if you have isolation problems with different projects, you try to find workarounds for these incompatibilities, for example, with these different versions of the compiler. But this may differ for each developer, because maybe I'm on project A and B, and the second developer is on project B and C. So he has other problems with isolation. And also the problem where I broke the whole environment, I need to start from scratch, and this will take, again, this 1 or 2 days to set up the whole thing. So this is not what we want. An upfront solution is to separate each environment from each other. So we have an isolated environment for each project, and we automate the whole process of setting this environment for each project. So we have, at the end, reproducible and automated environments that are completely isolated, or they have an isolated environment as they need. And this is because not only the source code of our product is a crucial part, but also other things, for example, like the development environment. This is also a good point, because you should have all things of the project in a version control system. Today, this sounds very clear to most everyone, but in the early days, this wasn't the case. But still, we should emphasize this, because not only the source code, which usually is at the top of this list, has to go into a version control system, but also the build system, the CI/CD pipeline, the mentioned development environment, maybe even IDE settings, and also the runtime infrastructure where the product will live at the end. So continue to this reproducible environment. How can we do that? The first thing we have to question us is, where should the border be for this isolation, and where should this environment go? The first point is what we do not want, or this would be the case if we want to install it directly on the machine. My memories were that at studies, I usually did that for each semester, and after the semester I destroyed the whole machine and set up it again, because it was very hard to maintain this environment for another semester with different tools. So this is exactly what we do not want to. The first variant is to use a virtual machine, maybe local on my laptop, local on my physical machine. This is the full-blown isolation variant. So there you have a clear border at the end of the virtual machine, and you can have everything in the machine and have no problems with other environments. Maybe you are not, or your laptop is not sufficient for these performance tasks of running a real VM. Maybe you have a virtual environment in your data center in your corporation. Maybe you can spawn there your virtual machine. This could be another option. The second option that is today really well established is to use containers. They may run directly on the physical machine or also in a virtual machine. This doesn't really depend, but containers are some kind of lightweight and faster way to solve this problem, because we can isolate something in such a container, and share only a small part with all other environments. And some kind of the third option, but is usually also based on containers, is in the cloud. We have multiple cloud providers that have such solutions where I can set up my environment in a thing like a container, and it will run in the cloud somewhere, and I only get the front end to the environment, for example, with VS Code, where I can work in. All the encapsulations have to be done by a tool. In the virtual machine case, most of you will know those terms. We can use VirtualBox, which is kind of open and free. We can use VMware, or we can use Hyper-V if you're based on Windows. This will help you to set up your virtual machine and have the whole isolation with the hypervisor, and to automate the whole setup of the tools in the machine based on your operating system. You can use tools like Ansible, which is well known in DevOps and other infrastructure projects, and also Vagrant, which is kind of the companion tool for such things like Ansible, to automate the whole process to set up and provision a VM. The other case with containers, you use Docker or Podman. This is well known in the industry. What is not so well known in industry is that there are different runtime engines for the whole container part behind. The default is usually runc, which is the default in Docker. There is also another implementation, which is crun, but the main difference you can have is with sysbox. This is an approach to try to let a container behave much more like a virtual machine, because usually a container does not really abstract all things of your operating system and hardware and kernel and so on, only a part of it. But Sysbox tries to get there where you have a real, or a container that behaves something like a real virtual machine, where you can easily, for example, run systemd. This is not really that easy, or it gets better, but it's not really for that meant in the normal runtime. And there are also other approaches like dev containers. I will go into that later, which allows you to add more metadata to your Docker file, for example, how this development environment should then be run in your IDE, or how it should be started and linked in with the source code. And all of this depends a little bit of your use case. Also, this slide depends on your use case, where you says, where is my border, where should my isolation end? So what should be encapsulated in my environment? If you start with a VM, you have all of this in your environment usually, but you can also decide where the border is. So possibility is you start with the operating system at the whole in the virtual machine. Usually you will have the compiler and runtime installed also there. You may have libraries installed in your environment that you are using in your project. Sometimes you even have hardware that you depends on, for example, a debugger for your embedded device that needs specific drivers. So you want to have these drivers in this environment installed, and then forward this hardware into, for example, the virtual machine. The IDE is a case where today it's not really needed in the environment itself, but can also be done. In my case, I have all things, also the IDE in the environment installed. And there are multiple other tools, for example, like linters or formatters, that also are part of your tool chain in your project. Here I have now two examples that may get you kind of insight how such an environment can be designed. The left one, this is usually my use case as embedded Linux developer, where I usually want to exactly choose the version I want for each tool, and I want to have all tools in my tool chain in my environment, because development on embedded devices is usually a little bit harder or not that stable as, for example, in a web development environment where it doesn't really matter which exact version you have. So in my setup, I usually have an Ubuntu LTS OS. I install my Yocto SDK, where also the compiler gets installed with the exact same version that is defined for this project. I usually have my IDE installed in there, in this case usually CLion. I have some libraries, for example libfmt, installed with the exact version I know I want to use. And for example Clang format as my formatter is also installed in this environment. But you may have other use cases. For example, as a Python developer, you may get away by simply installing some kind newer version of Python, 3.x, whatever, and you manage only your dependencies. For example, with Poetry, you can manage all your libraries and define there which version you want to or which lowest version you accept, something like that. And the IDE may not even be in your environment. It's simply directly installed on your PC, for example, VS Code or PyCharm, and you connect with the IDE to your environment. Already mentioned before are dev containers. This is not a tool by itself. This is only a specification for how we can use containers for such a thing like isolated environments. So dev containers and the page itself gives only a specification how we can enrich containers with development-specific content. This is kind of a metadata, similar to Docker Compose, where you define how you connect networks to your container or how you mount files in it. So this whole thing is still based on Docker images, but you can extend it with such metadata. Exactly. So usually if you want to have your source code available in the environment, you have a bind mount into the container, so you do not need to sync something between them. You simply bind it and mount it into the container. And for example, if you're a web developer, you may also have some kind of port forwarding, so you can access with your local browser into the environment to your web application that you are developing. Such tools that already use this concept are very established already. For example, VS Code and JetBrains tools have already such integration in these tools to work with such dev containers. And there are also other platforms, mostly in the cloud, which also use kind of, or sometimes they use directly the dev containers concept, or they use another approach based on something like a container to give you such an isolated environment. There are GitHub code spaces, Gitpod, and other projects that are trying to do that and give you some kind of such an environment, but in the cloud, so you do not need any performance on your local machine. But always think about this is public. These are public servers or somewhere in any location on the world. So you have to think about licensing and so on, and check that with your customer. You do not want to have your proprietary source code somewhere in the cloud accessible for Microsoft or whatever company you do not want to. With the IDE, there are also different approaches. I already mentioned some of them. These are the four main use cases. The simplest one in terms of how does this work is to simply install the whole IDE also in the encapsulated environment. So I connect somehow in the environment and then start the IDE directly in it, so it can simply access the source code that is checked out in the environment and work with that. There are multiple other versions or levels of IDE usage. For example, some IDEs uses some kind of backend, and you install only the backend in the environment, and the front end of the IDE is installed directly on your local machine, and the front end connects then to the backend. This is, for example, the use case with JetBrains Gateway, which is sadly still in beta, but it's some kind of a solution for this case. Visual Studio Code, for example, does it a little bit different. There you do not have to install anything in the backend part, but you simply connect with the ID to your remote, and your remote can be anything, a local machine somewhere in your network or a container, and Visual Studio Code will install the backend part automatically in the environment and will, like this, work similar, but the installation process is a little bit different. And you can also have a third option where your ID is not running anything in the container, for example, but it simply synchronizes, usually also with bind mounts, into the container the source code, and then access only the environment in the container and runs the commands, for example, triggering the build system. So the only thing that is injected is the source code and single commands that are triggered in the environment. Here I have a list of all these variants that these two main product lines offers. So you have all the JetBrains tools and all the Visual Studio Code variants that are supported. I will show you now this one and the one that where I installed the ID directly in the virtual machine. Okay, my usual workflow. This is this first example. As I mentioned already, the Jumpstart VM, which is based for these courses, is also in this use case. I have a full VM, which is automated and scripted. It's usually based on Ubuntu, and the whole automation and deployment process is automated with Vagrant and Ansible, as I previously mentioned. In my case, I usually access then the VM with X forwarding via SSH, but you can also directly set up a complete desktop environment in the VM and access it with the virtual environment from your hypervisor. But for me, X forwarding is usually the best case, and it works very well with all the JetBrains tools. This is a little bit heavy, but I have a full encapsulation. I have not to worry to have some interference with other parts or some limitations, maybe like containers. There are still some limitations in VMs. I do not have that. I can show you now a little bit how this works for me. Here you can see this is this virtual machine that is running in VirtualBox. In this case, it is installed with a full desktop environment, which I could also show here directly in the renderer of VirtualBox itself. But in my case, I usually simply connect with PuTTY, with SSH to the VM, and then use X forwarding to open all my tools. For example, the Git tools, or also my ID, which now looks like it is running on my Windows, because the X server is running on Windows, and the whole desktop environment is used on Windows. So all the applications are directly rendered on my Windows desktop, but they really are running in the VM. And this is very helpful also to have multiple projects. I simply start all the VMs for my projects, and I can open all the tools in these different VMs, but I still have one desktop where all the applications appear. So I can have multiple IDs open, and they look like they're running on the same place, but in reality they're running in different isolated environments. Yes, and this depends a little bit how well it works with X forwarding. So JetBrains tools works very well. VS Code sadly not that good, but it works at the end if it needs to. And the second use case I have is the one with the Docker toolchain, which I use with CLine. So I define my whole toolchain in a Docker file. There is the compiler, CMake for the build system, all my libraries, Boost, and etc. All my things that are using for C++ development. And I then create a Docker toolchain in CLine. When CLine knows now how to spawn this environment, and it will spawn on the fly this environment. First, he mounts the source code into this environment, and then he simply triggers the build process, for example, Make or Ninja or whatever you are using. And this allows me also to debug or whatever in a complete isolated environment. This is a little bit more lightweight and faster to restart because a VM takes always some kinds of seconds or even minutes to start up. Containers are really fast. This is a little bit on the faster side in this case, but there are still some rough edges. If you're doing some special things in your environment, there may be some problems with containers because you have some kind of shared resources, for example, the kernel with your host environment, and may have problems or interference there. Okay, this was it for my talk. Thank you for attention.
Thank you very much, Christian, for the interesting talk. So now is the time for Q&A. Does anyone have any questions? Just raise your hand. I'll bring the mic to you. Yes.
Thank you. My name is Zach. The question is, do you lose a lot of your performance when you run your project on VMs?
No, usually not, because the virtualization technologies today are really good. You have hardware support for virtualization in your i7 or whatever processor. You simply have to enable this in your BIOS or UEFI and sometimes tune a little bit of your environment, but usually you do this once for your physical machine, and then all VMs have the same performance, almost the same performance as if you're running locally.
Okay, thank you.
One side note to this, sadly this is today really some kind of problem. If you're running WSL or Docker in your Windows environment, your Windows environment is running in reality in a virtual machine in Hyper-V. You do not notice that because this is done by Windows automatically when you activate WSL or Docker. And then, for example, VirtualBox cannot access all the hardware features for the virtualization. So in this case, you have kind of a little bit slower virtualization and sometimes a little bit more unstable, but it's getting better. So for 2 years before, this wasn't really usable for me, but usually it works now. It's only a side note to mention. I personally do never install WSL. I always work only with virtual machines, so I have no problems, but usually today it may be a problem for you.
Any more questions? Oh, sorry.
Thank you. I'm guessing then there's also kind of some support system for like the securities that you don't necessarily have, you know, the isolation breaks. Is there kind of some testing systems you have in place to check that I mean, if you already have the different VMs, do you also then check that they don't interfere with each other as well?
No. Well, because usually I assume that the virtualization technology already provides this security. And it really doesn't really depend, or it's not really necessary because I'm not in an environment where I'm running production code or something like that. For this case, running production code, there is another level of security needs, but in the development environment, usually it's not. And I'm working about 5 years or so with this whole setup, with multiple projects, and in this case, I have had never problems.
Thank you. May I ask if you have any experience with remote desktop usage? I've tried JetBrains remote, but it has lots of bugs, especially when you click on some preferences. Some button just won't work. And I've also tried Xserver, but since the image is completely uncompressed, so the quality is largely dependent on the network quality. So is there any more elegant way to have a great remote desktop working experience? Thank you.
Are you referring to JetBrains Gateway or simply remote desktop from Windows, for example?
I've tried to use JetBrain
Gateway.
gateway to connect to my remote Linux server.
Yeah.
But most of the function works. But when it comes to some detailed preference settings, maybe the gateway hasn't implemented that kind of like setting UI. So they basically use an X server to basically output the image of the remote server. So it didn't work well. Yeah.
Yes, I have experience with that. I can also tell you how I work in home office usually. For the JetBrains gateway, I mentioned already, it's still beta, so you may have some problems in some UIs or some things that do not work. I not used that in my daily business until now because I usually get into these places where it doesn't work that good. In my environment, I usually use simply Windows Remote Desktop, RDP. When I work in home office, on my home office machine, there is nothing installed, anything of my daily business in the office. I simply connect from my home computer to my Windows PC in SCS, and there I run all my tools, all my virtual machines, and there I run my local SSH connection with X forwarding. So, and as you already mentioned, X forwarding is not really optimized for traffic over large or long networks. It works well on local networks, but over the internet it's not really good for that. There are new technologies that may improve that. Wayland sometimes may get some similar functionality, but right now we do not have that. Yeah.
One more question from me. Can we say that this functionality is more applicable to outsource companies which work on different projects with different other clients and companies and so on, so they have different properties for example, VS Code for one client and second client. So do they need to use this or not?
Yeah, possible. I can imagine that usual corporations that work simply on one product and use always the same environment, they do not need something like that. But I still would say them that they should use it anyway, because it also helps to encapsulate your environment for the CI part. So your CI pipeline also needs something of an environment that can be run on your GitLab server, for example. So you already need some kind of toolchain environment there. And why not already use that existing environment in your daily business development parts? But yeah, there may be the possibility. In our case, I work on very different projects, multiple switches per day, so I need some kind of isolation. Main difference is they now have struggles with setting up the whole VM environment. But when they did, this is only done once per machine. When they did, now they have it really easy to set up another environment. For example, I usually have one, or right now I have an employee that works in my project, and I gave him my environment for the project, and he set up everything. Have a little bit of struggle with the whole virtual machine part, but then it runs, and now he came to me for the Jumpstart courses because I'm one of the lecturers there, and I give him the VM, and he says, "Oh, I know that. Okay, start," and it runs. So it's also the thing about you have it only once, this whole overhead, and then you can amortize the whole time. And also the environment itself, I memorized that I had also kinds of projects where I spent 1 or 2 days setting up everything. And usually you get to the point where, oh, okay, yes, I did forget to document this. Yeah, you have to install this tool and you have to set up this one. So this is not really, yeah, it's frustrating, not only for me as the new employee, but also for the other one that has to, yeah, excuse it.
So we would have time for one more question.
Thank you for your talk. Thank you, Mano, for walking up here. So does this now actually work like this in practice for you, that every project has its own VM image and everybody just pulls that image into their VMware or VirtualBox? Or does everybody still need to install the host VM or a guest system and then run Ansible on that?
Is the question if this is really the practice in my usual day, or what was? Yeah.
Yeah, if every project comes with its VM image for the environment.
No, because this whole approach is kind of forced by me, or a little bit established, and it's not so that all our 120 employees use this approach, but there are projects that are using that, and you also have always a little bit of difference in the level of the abstraction, because my setup is usually full-blown VM. This is not needed by everyone, as our Python example before. So usual projects, they have really different requirements, so they do not need this whole abstraction for all the tools. So they usually get away by, I have anyway a CI/CD environment, usually it's a container, and I can directly use this container for my daily business already. So the encapsulation size may differ mainly, but in some point this is usually done anyway, mainly for the CI part. But yeah, it's not so that all projects have its own VM in our company.
Okay, then thank you again very much, Christian.
You're welcome.
We have a small token of our appreciation for your talk. If I got the right one. Yes. So
thank you.
VIScon mug as a reminder for your, hope you good time here.